How was this?
Yes. Now, yes. Now it's
It's
perfect.
moving. Okay,
Yes.
great. All right, so let's see. About the sample preparation. Okay, let's go back to sample prep. So you have to do the sample preparation. So pre-treatment of your environment sample. Then next, homogenize the sample, and then use a cryo. And then you measure the weight of your sample. So for the unknown sample, we recommend to use first 0.1 milligram or less, okay, to prevent system contamination. Okay. Well, in case you measure a microgram order, a sample, then you can also use semi-microbalance if you use or you add inorganic diluents to your sample. Okay. We sell this also this inorganic diluents with here the calibration standards. So we developed a calibration standard. So this is a 12 major polymers mixture, okay, already mixed with the either SiO2 inorganic or CaCO3 inorganic samples. Okay, this is the overview, okay, of sample prep. So you place in a sample in a sample cup, and then measure the weight, weigh the sample. Then cover up the sample with a quartz, or if auto-shot sampler is used, then your samples are ready for analysis. All right, so the next is the analytical measurement. So you place a sample cup on a sample tray of the auto-shot sampler, as in the picture here. This is auto-shot sampler. At the top, you can see the sample tray. So you place a sample in a sample cup here. You can load 48 samples maximum. Then next, you input analytical condition. We already optimized the analytical condition using our system, so you do not need to optimize pyrolysis and GCMS conditions. All you have to do is just follow our analytical conditions. Then once system is ready, then you start GCMS analysis. So this is a pyogram of microplastics actual calibration standard sample. So 12 polymers pyograms. So you can see many pictures appear on the pyogram. When you analyze environmental samples, you do not know what plastics and how much of them exist. Indeed, when we pyrolyze a mixture of plastics or polymers, we found peak overlapping and also abnormal peak shapes, which leads to inaccurate qualification and quantification. So to solve these challenges, we developed two new products. One is UAMP column kit. Another is Py-GC glass insert. So UAMP column kit consists of pre-column, which has a 2-meter length and a medium polar stationary phase, and then metal connector, and the main separation column, which is 30-meter length, and then 0.25 ID, and then 0.5 micrometer film thickness with the low polarity. Here explains, the right hand explains the improvement of peak separation. So without this UA pre-column, you can see that the marker peak of nylon 66 is overlapped with the pyrolysates of polyethylene. With UA pre-column, then the peaks well separates. And another advantage of this pre-column is to lower the risk of contamination of the separation column here. So if something is wrong with the peak shape, then just replace here the pre-column. It is cheaper way to maintain your system. All right, another product is the Py-GC glass insert, which is to improve peak shape. Okay, the pyogram above is the one obtained using a regular GC insert without packing material, and the bottom one is with packing material. So when we compare these two pyograms, you can see that from C20 to or C30, then peak shape, actually peak height is lower and then below the peak in the stem. If you compare here, okay, this is enlarged picture. So you can see the peak shape is different. So using this Py-GC glass insert, you can improve the peak shape. Again, because we don't know how many plastics or how much plastics exist in environmental sample, it is important to improve peak shapes and peak separation as much as possible beforehand. All right, once you obtain your data, then it is time for interpretation. So first, you need to search marker peaks for each polymer on biogram. Then you quantify each polymer based on the calibration curve. So for instance, for the quantification of polyethylene, we use the C21 monoend ion M/Z55 from EAC and then create calibration curve. So as such MPs, the software can automate qualification and quantification work for you. Okay, this slide summarizes search algorithm of F-Search MPs 2.0. If you want to know more details about searching algorithm, we published a journal paper, so please refer to this paper. Okay, this is a brief explanation. So in the library, marker peaks of characteristic ions, EIC, are registered. In the case of polystyrene, styrene dimer, and then monomer, styrene dimer and trimer. When searching polystyrene in your sample, then the software automatically detects EIC of characteristic ions of pyrolysates based on retention index. And plus minus 50, look for the peak. Then obtain mass spectrum of something peak A here, this range, and then peak B. Then the sum up the mass spectrum of peak A and then B, okay? And then create unique mass spectrum, integrated summation mass spectrum of peak A and then B. Then lastly, calculate the matching quality, so matching percentage of the mass spectrum between unknown sample and registered polymer in the database library. This is how we search a polymer in your sample using F-Search MPs. Okay, F-Search MP's operational procedure. So it has 4 steps. So step 1, creating a plot of retention index and retention time, then creating a calibration file or calibration curve, then do qualitative, quantitative analysis. Okay, searching result will be displayed, and then make sure we do the confirmation of searching result. Okay, let's take a closer look at each step. So step 1, creating a plot of retention index. So retention index is created based on the pyrolysates of polystyrene in Microplastics calibration standard. Again, we also have this calibration standard too. So this is a snapshot of our F-Search system. So you just click it, and then the software automatically find out or calculate retention index based on toluene, styrene, monomer, dimer, and trimer. And then step 2, you create calibration curve, okay, based on quantitative EIC peak for each polymer. Software will do this, so all you have to do is you analyze your calibration samples. Okay. Then next, you search your actual environmental sample, and then you get this qualitative, quantitative data. So this is a snapshot of resulting table. So on your left-hand side, you can see a summary of qualification quantification. And right-hand side, you see the mass spectrum peak shapes information. Okay. Let's take a closer look for each So this is a resulting table. From the table, you know the plastics name, library matching quality, how much, and the relative amount in weight, peak area of marker ions, and retention time. And then LOQ. LOQ, you need to input this number by yourself. You have to decide LOQ. And then last, you can see the bar graph of relative amount at the bottom of this table. And the last step, confirmation of searching result. So make sure your result or searching result by software is the right peak. Okay. So either you, in case of polyethylene, you can see the peak shape and then also the retention time and as well as the mass spectrum information. So you compare these information and then make sure the software detect right peak based on the peak shape and also mass spectrum information. All right, so let's move on to F-search demonstration. All right. Okay, let's see. I switched the. Okay. All right, can you see? Anuja-san, can you see F-search software display?
Yes, Ichi-san, it is visible.
Okay, great. All right, so this is the F-search MP's display. All you have to do is first you calculate a retention index. Okay. So you just upload database, the calibration data. So you go to calibration. Okay, I analyze actually the 4 milligram of calibration standard. Okay, and then I uploaded this data file. So you go to F-search, MP search, and then just click retention index calculation from standard sample. You click it. So software automatically calculate retention index for each compounds. Okay, and then if this is okay, press OK. So now software understands the retention index. And the next step is you create a calibration curve. Okay, you go menu bar, create calibration curve. So now you see the small pop-up window here. So first all you have to do is here. So let's see, I want to create calibration curve. Data point, maybe 3 data points. And maybe repeated one. For this time, I don't have much time, so just repeat just 1 repeated ones. Okay, usually you use the 3 repeated or 5 repeated ones or more. Let's see, this time 3 data points and the 1 repeated one. So you punch here data point, number of data point. All right. So I upload data file. So this time I analyze about 4 milligram of calibration standard. Okay. I analyze 4 milligram of calibration standard. Okay. And then in 4 milligram calibration standard, how much polyethylene or those polymers are there? Well, when you purchase this calibration standard, it comes with the quality as the standard testing results. So you just punch the number. So in this case, polyethylene in 4 milligram, we have 145.5 microgram of polyethylene. So I do the rest the same. So 5.2, 5.3. All right, 2 more. Okay, once this I input it, great. So let's upload the next data point. Let's see, I analyzed 2.03 milligram of calibration standard. In this case, I just put here 2.03. then automatically calculate the amount of polymers. Okay. Then last data point, let's say 0.4 milligram of calibration standards. So I put 0.4 milligram and then press apply. So automatically change the numbers. Okay. Once this is okay, then you press the next. So now the software is creating a calibration curve based on the data set I just uploaded. Again, if you want to increase the number of data points, you can do that. And then also if you want to upload maybe 5 repeated runs, then you upload 5 files. Okay. But for this case, to shorten the time, I just only upload 1 file. Okay. So the software almost finished creating calibration curve. Okay. So this is a calibration curve result. All right, so when we get this data, let's check EIC, the peak shape, integration range is the right one. If not, you can change it from here. Let's see, drag, right drag, and then like you can change right away. Okay, so this is okay, then just leave it. You check each polymer, the marker peak, make sure the integration area is right. Okay, also the linearity. Okay, here the software looks like a weird connection, the peak, but actually there is a quadratic, the peak, the calibration curve is used. Okay, so you check each peak, and the shape is okay, then press save. Right. Okay, so test today. I just put test and then okay. So now you just saved your calibration curve data. So next, let's analyze environmental sample. All right, so you go to sample data. Let's say I upload this unknown sample. Okay, then next I upload the calibration table. I just save, so test. Okay. Then go to the menu bar and then you click search microplastics. All right, so the software is now searching whether certain polymers are included in the sample. Depending on the data file you uploaded, then maybe it takes time, a few minutes sometimes. And then also depending on your laptop's the specification as well. All right, so we get this data. So this is resulting summary table here. So you can see first polymer name and matching probability and quantification amount and the reactive ratio and then peak area of marker peak, marker ion, and then retention time. Okay, let's look at polypropylene. Yeah, I click here polypropylene, and then you can see this is the polypropylene's result. Here is your data, and then this is the calibration standards data. The mass spectrum, when we compare mass spectrum, okay, looks okay. But where are the polystyrene? Let's see. The one next here. Looks like the mass spectrum information is different. Let's look at the peak shape as well. Oh, peak shape as well. If you click here, EIC, then this is EIC. So you can see that comparing retention time and then also the peak shape, definitely polystyrene is not included. And then you do the rest. So for example, back to polypropylene, you can see that this is your samples data. And then this is calibration data. you can compare it, and then retention time is right, and then mass spectrum information is right, so polypropylene is included in the sample. What about the quantification amount? 20.29, that's quantification amount. Also, there are a couple of polymers which has a whose matching quality is below, let's say, 80. For example, if you do not believe any polymers that does not have over 90% matching quality, then there is a threshold. So you can set, let's say, 90%. Then just screen out all the polymers which does not have above 90% matching quality. Also, you can screen out the quantity by quantity. Let's see. I forgot to put LOQ, but if you put LOQ, let's say PMMA. Let's look at PMMA. PMMA, let's see. Yeah. Spectrum looks okay. EIC. Well, the signal to noise ratio is not satisfied, then you think that this is not included. And then you can screen out. And then so in my conclusion, then this sample contains polypropylene, PVC, and polycarbonate. And for each, about 20 micro, 6 micro, and then 2 micrograms. You can export this table result in a CSV format as well. All right, this quickly I just show the demonstration of SHMPs. All right, then now I back to the presentation slide. So thank you very much for listening. So this is a summary. So microplastics analysis by Frontier Labs Py-GCMS. So we have calibration standard and optimized analytical conditions. Okay. And then also you can automate quantitative and qualitative work by searching software SHMPs. This is for your information. This is the Py-GCMS system configuration list. Also, there is another challenge that lots of researchers now want to analyze a nanogram order. Well, it's quite difficult at this moment, but we are trying to make it happen by developing new optional devices. These devices allows us to do splitless pyrolysis GCMS. So it improves the sensitivity more than 10 times. Okay, this will be announced soon. Also, for homogenizing sample, we are going to release a new cryomill, very small, handy, and then portable, and then suitable for polymer sample. All right. Thank you very much for your attention. Sorry for the trouble. I had to skip some of the contents, but if you have questions, please let me know. Thank you very much.
Thank you, Ichi-san. If you have any questions regarding when the first talk and also the second talk, kindly drop all your questions in the Q&A questionnaire box.
Yeah, Anushashan, yeah, can you read the questions so we can take those questions one by one?
Sure. Let me go through the questions one by one, and meanwhile you all post your questions. Yeah, the first question, I think it's for the Karthik-san talk. Can you share the sample preparation method for drinking water?
Yeah, I think if I'm not mistaken, this was posted before I was explaining the sample preparation, because The sample preparation, I kept it last part of my presentation. Yeah, basically,
Karthik-san, are you there?
yes. Can you hear me? Hello.
Yes, I
Yeah,
can hear.
Karthik-san.
Yeah, you can hear me, right, Anusha-san?
The first question is for Karthik-san, I think so. Can you share the
Correct.
sample
No.
preparation method?
Yeah, no, but do you listen? Can you listen me? Like, can you hear me?
Yes.
Okay. Yeah, so I think I was trying to tell that this was actually shared at last part of my presentation. Maybe this question popped up before that. Yeah, I think by end they would have got the answer for this question. For drinking water, it is basically a direct filtration by using a quartz fiber filter. Okay, of this smaller size like 10 mm, also the pore size of 1 micron or 0.2 micron. Then this filter paper can be directly analyzed by the pyrolysis, the PY system directly.
Maybe Ichi-san, I think you can answer it. And meanwhile, Karthik-san comes on stage.
Okay. I think he explained it. What do you mean by the questions?
The question is regarding the sample preparation for drinking water.
Water sample, right?
How to prepare
Yes.
drinking water
I think
sample
Karthik-san.
to get microplastics extracted and put into the PY sample cup properly.
Okay, so I think in his slide he explained it already.
Yeah.
So I don't know the same. So basically you use a filter.
Yes.
But in case of nano size, then depending on the filter size, then you will miss those small microplastics. Okay, that's another challenge that we need to face.
I think.
And there is no solution yet.
Yeah. I think that question is.
Yeah, I think there is some kind of connectivity issue at the Anusha side. So because of which that she's not able to listen my voice, I think.
Oh, is that so? Ichi-san, now Karthik-san, your voice is audible, but earlier your voice hasn't audible.
I see. Yeah. Anyway, because I answered this question, maybe that time you could not listen, I think.
Yeah.
Then, it is also repeated, so it should be okay. Yeah. So we move on to the next question.
Okay. In case of FTIR, ATIR, polymer library database is recommended to be installed in our PC. Whether such library database is required for Py-GCMS as well, or we can use the previous literature. Example, the PPT slide which shows marker ions of different polymers and consider it reliable.
Okay, Jisan, I will answer first, then you can add. Yeah, so if you want to use the marker ions, what I have presented, it's possible. Some of the researchers are doing that, but your data analysis work or process can be easy or faster if you use our software. You don't have to have a separate database or anything. Our software comes with the inbuilt library, so it's easier and faster. Yeah.
Okay.
Yes, he's right. So I don't have anything to add. But if you don't need to really, if you don't want to use F-Search MPs, that's okay. But in that case, you have to do it manually. Okay.
Okay. Can I move on to the next question? Yes. The next question is how to analyze inorganics present in micro or nanoplastics.
Okay, so this is something we cannot do with Py-GCMS. Like in ICP-MS, they are doing nanoparticles analysis. So if you are interested in inorganics in nanoparticles, or because there are some reports that says microplastics can carry some inorganic nanoparticles. So such analysis can be accomplished only with the single particle analysis by ICP-MS. Yes, move on to the next one, please. Yeah, Anusasan is lost, I think. Yeah.
Okay,
Okay.
I think she cannot.
Yes, Karthik's
Now
voice
she's
is
back.
not at all, audible to me, so I'm seeing his answers. Anyways, can I move on to the next question?
Yes, please.
Next
Yeah,
question
please.
is how to introduce MP flake contaminations into pyrolyzer less than 100 micrometer. This sample weight much less than 0.2 microgram.
Okay, I can answer the question. So maybe the question can be maybe clarified, but I assume that the question is one particle, the sample weight is 0.2 microgram. Well, in that case, please use maybe the 10 particles or 100 particles so that you have the enough sample amount to analyze your sample. If not, then it's quite challenging sometimes.
Okay.
Yeah, unlike the spectroscopic technique,
Next
it
question
is
is
not like
how to analyze
compulsory.
semi and
Yeah,
non-volatile compounds in Py-GCMS.
Okay, this is maybe asking about the POPs.
yeah, I think yes.
Yes, in that case, you do the thermal desorption. Let's say for microplastic analysis that I presented today is you apply 600 degrees C. But for POPs, maybe you apply 100 degree to 300 degrees C to lower temperature zone. In that case, you can separate additives or POPs information from polymer information.
Okay. The next question is
Pyrolyzer, you can do it.
okay. Next question is how to analyze the concentration of additives in plastics.
Okay, maybe I just, well, you do the thermal desorption GCMS method. But again, concentration of additives means you need to have certain standard. Okay, and then create calibration curve.
Okay. The next one is how to check materials like polyhema or silicone from contact lens. Check materials like polyhema or silicone from contact lens.
I don't know polyhema.
Yeah. So,
Silicone from
Ichi-san, do we
contact
have any
lens.
application in contact lens industry?
I think let me double check. So I will get back to you. I will
Yeah.
check
So yeah, sorry. So
applications.
unfortunately, we cannot answer your question now. So please drop us an email. So we will get back to you.
Yes. Jitendra-san, kindly drop an email with this query and we'll get back to you. The next question is he wants to know the sample preparation for extraction of microplastics in water, which is we already answered. I think so.
Yeah. So let me repeat one more time. So extraction of microplastics from drinking water is through a filtration. Normally for suspended solids, you do a filtration, right? So basically collecting the particles on a filter paper of lower pore size. Generally, we recommend 0.2 micron for drinking water, or for natural waters, it can be even 1 micron, because natural water will have more of suspended solids. So these suspended solids will form a cake that will reduce the pore size, so that will ensure that you are not losing any particles. Yeah. So it is basically a simple filtration. Yeah.
Okay.
Okay, next question.
Yeah. The next question is how to prepare homogeneous mixture of different polymer standards to do quantitative analysis of different polymers identified in microplastics. Just to know the concentration accurately, it is possible. For this, I think he already got the answer, but now he wants to know the uncertainty of measurement associated with the analysis.
Okay, Ichi-san, so you can either add or I can add also.
Can you answer the questions?
Yeah, basically, I think this question popped up before Dr. Ichi-san's presentation. So I am sure that you know that now we have a standard mixer. Okay, so that is actually something homogenized. So if you are doing something in your laboratory, yes, this will be a challenging task, but we provide or we supply this standard mixer, which is fully homogenized. Okay, the second question is based on the uncertainty. So it is on what is our RSD for multiple analysis? Something can you share?
Okay. RSD for the calibration standard.
Yeah.
Okay. If depending on the sample prep, and usually below 5% or 3%, that's our regular RSD value for standard samples.
Yeah. So yeah, I think so we can say as a rule of thumb for our Py-GCMS analysis, but when it comes to trace analysis, definitely the RSD will be slightly higher. So we can say it's 5%. But when you do real samples with some spiking experiments and all, it can go up to 10% also. But generally, as you know, for trace, ultra trace analysis, such RSD is something is expected and acceptable. Yes, Anusha-san, are you there?
Yes, I'm here. I don't know what technical glitch is going on. Only after answering the question only I could hear your voice. Yes, the next question is specifically addressed for Dr. Ichi-san. For calibration point, do we need to consider only quadratic curve fit type of quantification of polymer in microplastic analysis? Can you please confirm it?
Okay, if you use F-Search MPs, then the software is quadratic, the calibration curve. But well, some scientists they use just straight the linear curve. So it depending on the analyzer. So the scientist, you can either choose either method.
Okay.
So our software comes with a quadratic fit.
Yep.
Okay, thank you. The next question is regarding the supplier that collaborates with the Frontier Lab. I think for this, they need to drop us a mail regarding with region specifications and all. The Noor Salmi San, Abdullah San, kindly drop us a mail for the collaboration, or for the distribution channels and all. And people who want to ask questions, kindly drop your questions in the Q&A questionnaire session, not in the discussion session, such that it will be clear. Yes, the last question is how to get microplastic particles from microplastics. I mean the grinder or thermo used. Okay.
Can you say that again? Sorry,
Yes.
I missed.
How to get microplastic particles from the microplastics, grinder or the thermo used. That's what they dropped. Okay, sorry. How to get macroplastics to microplastics. Okay, now the question is clear. How to get macroplastic particles from microplastics.
How to get microplastic from macroplastic?
Macro to micro, I think. No,
Okay, so
microplastics from macroplastics typo.
Okay, it's typo. Okay, then use the cryo mill.
Yes.
Yeah. to make it fine powder.
Yes. As Thomason, you mentioned you can use the grinder. It's nothing but, as he said, the cryomill.
No, I would say cryomill because maybe the polyethylene, I don't think you can make it smaller particle. It's very soft. The polyethylene is very soft, and then also other polymers. In case of very soft polymer, then I don't think you can just grind it. So make sure you use the liquid nitrogen and then crush it.
Yes, any kind of cryomill. Is there any specific configuration, Ichi-san?
Well, I think many suppliers, they have lab equipment, the cryomill lab equipment. So let's say we will going to introduce our cryomill as well, and then also you can find the commercialized product specs. I think they sell cryomills.
Yes, Thomason, soon we are going to introduce the exclusive Frontier cryomill. You can wait for it, or else meanwhile, as Ichi-san mentioned, depending on your need, there are many kind of cryomills available in the market. I hope the questionnaire session, yes, it's done, because these are all the questions we received till now.
Yeah, sorry, there are some questions that we missed.
Please drop us a mail or visit our website for more exclusive Frontier products, consumables, new launches and all. And also a lot of technical notes and newly launched application notes are also available on the website. Now I hand over the session to Karthik-san.
Yeah, thank you, Anasa-san. There are some more questions that we missed, I guess. So I think I will read. Ichi-san, are you there? So maybe I will read for you.
Yes.
So that's one question. What is the purpose of doing UA-MP and packed glass insert?
Okay, so the UA-MP column is to make sure your marker peak is well separated. Okay, improving separation, then you get accurate quantification result. Because some of the peaks are overlapped, so the data is not accurate. So that's the reason why we use UA-MP column, actually the play column. And then for the GC glass inset, you can improve the peak shape of especially a polyolefinic polymer, so polyolefins or polyethylene, those peaks. Improving peak shape then will actually lead to the better quantification result, and then also repeatability.
Yeah. So
sorry to interrupt.
Continuation of that.
Yeah, sorry. Go ahead, Karthik.
Yeah, no, there are a couple of questions.
Yes,
I think we missed.
yes.
So I'm just reading.
Yes.
So yeah, it's okay. I can read
Okay.
only two more questions.
Okay.
So the second question to Ichi-san is actually the UA pre-column packed GC glass insert. Can it fit to any Py-GCMS or any specific brand only?
For UA pre-column, any GC. And glass insert, we only have an insert for now for Agilent GC and also Shimazu GC, those two types.
Okay, thank you. So the next question is for me.
Yes.
So if we use marine water column samples from the plankton net, would it be possible for us to identify the microplastics in it by using nail red methods? So this is something, it may fluorescence, but again, you need some further investigation through other methods, unless you are able to confirm that the fluorescence characteristic is of certain type of polymer. So I cannot give you a concrete answer for this. Generally, people are not really using the fluorescence type of approach, because some other pigments also can give interference. So far, I think the people approach is to use spectroscopic technique or a thermoanalytical technique. So, but it would be possible in principle, but it will have some limitation. Okay. So I think we have a repeated question again, how to quantify microplastic in water samples. So this goes back to my previous answer. Okay. So for water sample, you have to collect the particles on a filter paper through filtration. So it can be a vacuum filtration or some gravity filtration through some plankton net. Then you analyze this filter directly, either by a Py-GCMS system or if it is a spectroscopic technique, you basically scan through the filter for different particles, then look at the particles for the type of plastic present there. Okay, so the next question also is for me, how to ensure that the filtrate trap in the paper has inclusion of, this is a very good question, and this is something has to be done as part of the method verification. Normally, as you know, you need to run a verification analysis in your routine analysis. So we generally recommend, you have a water sample where you add the standard we provide, small amount like 1 milligram or 0.5 milligram. Then you filter this sample through a filtration like filter paper. Then you analyze, then that will give some kind of confirmation for this. But in principle, based on the pore size and also the filter cake formation, most of the particles should be trapped. Yeah, but the validation or verification can be done only through spiking experiments. Okay, so that's one more. Let me see. Okay, how to test metals absorption properties on microplastics. Yeah, this is more like so it depends, definitely it's out of our scope, but based on my experience I can share this, because if people are using different adsorbents for heavy metal removal, you basically look at the initial and final concentration after adsorption, or you can desorb the absorbed metals from the plastic by a chemical leaching, then you can analyze that. So either way you can do it. It's normal adsorption, desorption experiment. Then what is the match factor consider ensure particular okay, what is the match factor to consider in F-Search software to ensure the particular polymer? Jason, do you want to answer this?
Yes, we have a formulation to calculate the matching factor. So matching factor basically based on mass spectrum, so intensity and then types of ions.
Okay. I think
yeah, I think basically we recommend like this 90% matching probability. But again, if you are talking about some complex matrix, this probability matching can be a bit lower also. So this is something you have to optimize for your type of analysis. So it's very difficult to say that you use 90% or 95% across the analysis. That's something we cannot tell, because depending upon the type of sample you are working on, the recovery and everything other like factors, it can be, but generally we do not recommend to use such a low probability. So anything above like 80, 85, 90 is considered good. Okay, so I think we have tried to answer most of the questions. I think I see that we have 225 participants, but only like 100 people, or like earlier 130 people were on stage. Maybe because many of you are like not familiar with this platform, that could be a reason. So we are sorry for that inconvenience, because just to accommodate as many as participants possible, we have chosen this platform, and most of the virtual events are taking place in such platform only. So we were under the impression that you all may be familiar with this kind of platform. So it's a bit unfortunate that you have stayed for 2 hours, but not sure whether you have listened or not. So what we will do is we will send the recording is one thing. We will also consider to run this second round with this recording. So I will not disturb Ichi-san. I will do something on my own. So we will just run one more time through a Zoom or WebEx, where this kind of complex things may not be required. It's straightforward. But this is more of a fancy stuff. So that created some kind of inconvenience for some of you. So anyway, thanks for your efforts, and you all joined, and I hope you have got some useful message for you to continue your research on this topic. And we are reachable by email anytime. And as I said, I will have a follow-up email with all of you, where we will provide the recording, and we will also try to arrange another round of this webinar where it may be just by myself for 1 hour, but covering Dr. Ichi-san's topic also. Okay, so with that, I think we will end today's webinar. Thank you all, and I also would like to thank Ichi-san and Anusha-san for joining and giving hand for making this webinar successful. And I thank all participants for your interest, and I hope you have enjoyed. And any question, please do not hesitate. We will try to answer. Thank you. Have a nice evening.